Welcome back to our Chem 152 video series. In this video, we'll talk about how to construct reaction tables and how to use them to find equilibrium concentrations in a reaction. We are given the following reaction with a Kc value of 160. We have two NO2s yields N2O4. If we start with 2 moles of NO2 in a 5-liter vessel, find the equilibrium concentrations of both species. Solving an equilibrium question involves 3 pieces of information. First, we need to think about the initial concentrations. We need to think about the change in those concentrations. And we need to think about the K value for the equilibrium constant. Now, in this question, we do have the K value. Let's put a check mark next to that. And we're given enough information to where we could find the initial concentration. So the thing that we don't know is the change. Before we construct our table, let's find that initial concentration. To find concentration, we'll say that our concentration of NO2 is equal to our moles over our liters. Our moles are 2 and our liters are 5. If we divide, we will get 0.4 molarity. We'll write 2 NO2 gas yields N2O4 gas. When we construct our table, we'll have a line for initial conditions, a line for change, and a line for equilibrium conditions. We only know the initial conditions right now. The NO2 will be 0.4 molarity. The N2O4 was not given, which means that we can assume it's 0. We'll place a 0 for the initial position. Now, we don't know what the change is. We know the initial, we know the equilibrium constant, we do not know the change, so we will let the change be x. Now, since we have a 0 on the right side, we can safely assume we'll be reacting toward the 0. This means that we're going to gain some product, and we're going to lose some reactant. Now, when you write your changes, be mindful of your coefficients. The coefficient in front of NO2 is a 2, therefore we're going to say minus 2x for the change on the left. On the right, we have a coefficient of 1, so we'll say 1x on the right. Now we add or subtract to get our equilibrium concentrations. We'll have 0.4 minus 2x for our NO2, and then just x for our N2O4. Now we have the equilibrium concentrations in terms of x. Now that we know these, we can try to write the equilibrium constant. We'll write products divided by reactants. Our product is N2O4. Our reactant will be NO2. And this will be squared because there is a coefficient of 2 in front of the NO2. So we will write x on the top and 0.4 minus 2x, the whole thing squared, on the bottom. Then we will set this expression equal to our K value. Our K value given at the top is 160. So we'll say this fraction equals 160. Now we'll need to handle the algebra in order to try to solve this equation. First, let's remember that a binomial squared is equal to that binomial written twice. So we'll rewrite that denominator as x over 0.4 minus 2x times 0.4 minus 2x. Now that we've written this twice, we will multiply these two binomials using the FOIL method. We'll begin by taking the 0.4 times the 0.4. This will give us 0.16. Then we'll take the 0.4 times the negative 2x, which will give us negative 0.8x. After that, we'll take the negative 2x, the second term in the first parentheses, times the 0.4, which will give us another negative 0.8x. Then we will take the negative 2x times another negative 2x. Negative 2x times negative 2x will give us positive 4x squared. We'll combine any terms we can combine, and that would include these negative 0.8x's. And when we are finished, we'll get 0.16 minus 1.6x plus 4x squared. Then we will rewrite those binomials as this new trinomial. We'll have 160 equals x over 0.16 minus 1.6x plus 4x squared. Now what we can do is take this trinomial from the bottom of this fraction and move the whole thing over across the equals and onto the left side. Now our equation will be 160 times the trinomial, and we'll set that equal to x. Now once again, we will take the 160 and distribute this across all three of these terms. We begin by taking 160 times 0.16. Our first term will be 25.6. Then we take 160 times negative 1.6. This will give us negative 256x. Then we take the 160 times the positive 4x squared. This will give us plus 640x squared equals x. Now that we have this second power equation, we'll need to get it into standard form in order to solve it. In order to get this into standard form, we will now need to move the x that's on the right over to the left. We'll say minus 1x on both sides, and we'll end up with 25.6 minus 257x plus 640x squared equals 0. Now that you have a second power equation in standard form, we have three options with which to solve this. Option number 1 is to use a graphing utility. This is fine for the homework, but may not help you very much on an exam. Option number 2 is to use the polysolve function on most TI calculators. But for those of you without the TI calculators, I'll demonstrate this using the third option, the quadratic formula. The quadratic formula goes like this: negative b plus or minus b squared minus 4ac, and we'll divide both terms by 2a. First, let's get a, b, and c. A is going to be the term that's next to x squared, and so that's 640. Term b is the number that is next to our x, and that is negative 257. C is the constant term that has no letter, and that will be 25.6. Therefore, we'll have negative b, which is negative of negative 257. So you can think of this as a positive. Divided by 2 times a, which is 1280, plus or minus b squared. So we'll say root 257 squared. We don't need to put the negative because we'll be squaring, so it'll change to positive anyway. Minus 4 times 640 times 25.6, and then divide all of that by 2 times a. Again, that is 1280. Then we can go to a calculator to simplify these fractions. Our result for the first fraction will be 0.2, and the result for the second fraction will be 0.0177. Therefore, our first possible x is 0.2 minus 0.0177, and our second x is 0.2 plus 0.0177. Therefore, our first answer, when we subtract, is 0.18 0.1823, and our second answer is 0.2177. However, one of these two answers will not work in our reaction table. Let's have another look at the reaction table and find out which one of these won't work. What we'll need to do is see if our answers that I boxed in on the right make sense if we plug them in as our x. If x was 0.1823, our NO2 concentration would be 0.4 minus 2 times 0.1823. And our concentration for N2O4 would just be our x, which is 0.1823. If we do the subtraction, we'll get 0.0354 molarity for our remaining NO2, and then 0.1823 for our N2O4 that we've made. So there's no clear problem with these molarities. These seem to make sense so far. Let's try the same calculation if x was 0.2177. In that case, our NO2 would be 0.4 minus 2 times 0.2177, and our N2O4 would be 0.2177. If we do the subtraction, we would end up with negative 0.0354 molarity. As we know, there is no such thing as negative molarity, therefore this answer is invalid. That means 0.2177 cannot be our x. Our x must be 0.1823. Therefore, our equilibrium concentration of NO2 will be 0.0354. And our concentration of N2O4 will be 0.1823. So now, based on starting molarities and K value, we've found the equilibrium molarities of both the reactant and the product. Thank you for watching, and we'll see you again soon.